Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be looking at derivatives of exponential functions. So without further ado, let's just get into it. The first function I want to talk about the derivative for is probably the easiest one of this family. It's y equals e to the x. Now, if you don't know, e is Euler's number. As a decimal, it's 2.718, and it goes on forever just like pi. It's named after the probably greatest mathematician of all time, Leonard Euler. Pronounced Euler, not Euler, even though it looks like Euler. And what's special about this number, and especially e to the x, is that it's the only function in the world whose derivative is the same as itself. And so what that means is, if I want the derivative of y equals e to the x, then the derivative y prime is just e to the x. It's the only family of functions in the universe whose derivative is the same as the original function. Very cool. And then the only thing you really have to worry about is for a chain rule like this, where you have an exponent that's not just x, you've got 4x. This is the chain rule. If you forget the chain rule, I'll just tell you the shortcut right now. The derivative is e to the 4x, which is the derivative of the e to the x part, times the derivative of your exponent. Derivative of 4x in this case is 4, so times 4, and then that's it. You're done the chain rule. And if you want to write it a little bit nicer, you can put the 4 out in front, and then maybe this is how I would write it. So just one more time, whenever you have the derivative of e to something that's not just x, it's the same thing, e to the 4x in this case, times the derivative of the exponent, which is the chain rule part. And then probably the most complicated case you can see is something along the lines of y equals 2 to the power of 6x. This is still exponential because the x is in the exponent, but now we don't have base e anymore. The good news is, still very easy. The derivative y prime is, first rewrite 2 to the 6x power, always rewrite the original, then times the chain rule on the 6x, so that's times 6, because that's the derivative of 6x. And then, because this is not base e, you also have to multiply by the natural log of your base, in this case 2. Technically, we're supposed to do that for e to the x as well, but if you remember, the natural log of e is just 1, which is why we don't need to do that for e to the x, and why e to the x is our favorite. So now, that's enough of me talking. Now let's go ahead and do some example problems based on the rules I just showed you. I encourage you to pause the video and try them on your own first. So here's the first one, y equals e to the x squared plus 2x. What's the derivative? Pause the video, give it a try. And here is the solution. So first I'm going to say y prime equals, write the original, e to the x squared plus 2x, and then times the derivative of x squared plus 2x. That's going to be 2x plus 2, that's in parentheses, and you can just keep this as your final answer. That's perfectly fine. So that's it for that one. Here's the next one we have. Y equals 1/2 to the power of x. Go ahead, try this one now. See if you can figure out what to do with that 1/2. And here's the solution. So y prime is going to be, first, I still rewrite it, 1/2 to the x. The derivative of x is just 1, so times 1, you don't even need to write that technically. And then because this is no longer e, you have to write natural log of 1/2. And so then the final answer you can write as 1/2 to the x power times the natural log of 1/2. Doesn't matter what you write first, but this is the derivative. Okay, on to the next one. The next one, I'm not going to lie, has a little trick in it. See if you can solve this one now. Okay, so the secret for this one is the fact that we need a product rule. This is product rule because you have your f of x function here, x, and your g of x function here, e to the negative x. So what I got to do is, I'm going to say f of x is x, and g of x is e to the negative x. And then the derivative of each of these, f prime of x is just 1. G prime of x is going to be e to the negative x times the chain rule on the negative x. Derivative of negative x is -1, and there we go. Then putting it together with the product rule, it's f of x times g prime of x, so that, and then plus g of x times f prime of x. And then if I wanted to simplify this, I would simply, for the first term, write negative x e to the negative x plus e to the negative x, and there's our answer. Perfect. And then for the last two we're going to look at today, I'm going to tell you the secret is using your properties of exponents. So if you forget what that is, I cover it in a different video. You can check that out. But to solve this problem that I'm giving you right now, I want you to not use the product rule. I want you to use properties of exponents first before we take the derivative. And so if you know what I'm talking about, go ahead, pause the video, try it. And if not, just watch me what I do and then you'll understand. Okay, so here's the solution. First thing I do is I say because I'm multiplying these numbers together and they have the same base, I can add the exponents. Meaning, not the derivative, the original function, is e to the 2x plus x plus 4. This is one of our properties of exponents. So then the original function becomes e to the 3x plus 4, and then the derivative y prime is just going to be e to the 3x plus 4 times the derivative of 3x plus 4, which is just 3. If you want, you can write it like 3e to the 3x plus 4, and that looks nicer, so we'll go with that as our final answer. And now for just one more. Here's the last one. Y equals numerator e to the x plus 1 power, denominator e to the 2x minus 3 power. And remember, we're using properties of exponents here. What do we do when we divide with the same exponent? That's right, kids, we subtract the exponents. Very good. So that means it's going to be e to the power of x plus 1 minus the quantity 2x minus 3. Very important that you put that in parentheses. It tells us we need to distribute the negative to both terms. And so that means my original function is really e to the x plus 1 minus 2x and then plus 3. Again, that's after I distribute the minus sign here and here. And then simplifying this further, y equals e to the negative x plus 4. And that was fun, but remember I didn't take the derivative yet. So now to take the derivative, y prime equals e to the negative x plus 4 times the derivative of negative x plus 4, which is just negative 1. So it looks like our final answer is negative e to the negative x plus 4, and there's our answer for the derivative. So hopefully you found this helpful. If you still have any questions, please post them in the comments below. I hope you all have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.